A shaft is subjected to combined twisting and bending moments of 1500 Newton meter and 1000 Newton meter respectively. Equivalent bending moment in Newton meter is options are 1.401, 14.01, 140.1 and 1401. That is 1401. So here the equivalent bending moment is given by when a shaft is subjected to combined twisting and bending moments, equivalent bending moment is given by half m plus root of m square plus t square. So just substitute m and t values in this equation. M is 1000 Newton meter, that is bending moment, and t is the twisting moment is 1500 Newton meter, so that it is equal to on the simplification it is equal to 1401 Newton meter, and the correct option is D. If the ratio of diameter to pitch of the rivet is 0.33, then the efficiency of the riveted joint is, options are 47%, 57%, 67% and 77%. Here the given data is the ratio of diameter to pitch of the rivet is equal to 0.33, but the efficiency of the riveted joint is given by P minus D by P. So we can write as 1 minus D by P, but we have the ratio of D by P, so that it is equal to 1 minus 0.33, that is 0.67. So it is 67%, and the right option is C. If notch sensitivity factor is 0.9 and theoretical stress concentration factor is 1.4, then fatigue stress concentration factor is, and the options are 0.36, 2.36, 1.36 and 3.6. Here the given data is notch sensitivity factor, let us say Q is equal to 0.9, and theoretical stress concentration factor, let us say KT is equal to 1.4, then fatigue stress concentration factor is given by Q into KT minus 1 plus 1. So here Q is 0.9 and KT, sorry, it is KT minus 1. 1.4 minus 1 plus 1. So which is equal to 1.36. So and the right answer is C. C is the correct option. The velocity potential for a two-dimensional potential flow is given by x into 2y minus 1. Determine the velocity of the flow at the point 3, 4. The options are 9.21 units, 11 per second, 11.02 units per second, 14.2 units per second, 15.2 units per second. Here the given velocity potential flow is x into 2y minus 1. So to find out the velocity of the flow at the point 3, 4, first we will have to find out the velocity vector. So for that, velocity in x direction is given by minus dou psi by dou x. So it gives 2y minus 1 of a minus value, which is equal to minus, here that 0.3, 4, so at y is equal to 4, 2 into 4 minus 1, which is equal to minus 7. And coming to the velocity in y direction, we can get by using the equation v is equal to minus dou psi by dou y, so which is given by minus 2x, so which is equal to minus 6. Now the velocity vector is given by is equal to minus 7i minus 6j, so that the velocity at this point is equal to minus 7 whole square plus minus 6 whole square, so which is equal to 49 plus 36, and on the simplification we get v is equal to 9.21 units per second. We don't have specific units, so that either meters or meters per second or mm per second, so that's use units per second. So the correct option is A. A composite wall of furnace has 3 layers of equal thickness having thermal conductivities in the ratio of 1:2:4. What will be the temperature drop ratio across the 3 respective layers? Here the given options are 1:2:4, 1:2:1 and 4:2:1, and D is log 4:log 1. Here for a given heat transfer, the temperature drop is inversely proportional to thermal conductivity, because for for the for the conduction, the heat transfer is given by Ka dt by dx. That means here if K is high, obviously the dt is less. For a given heat transfer, if K is high, the dt, that is temperature drop, is less. That means here dt is inversely proportional to thermal conductivity. So that here the layers are in the ratio of layers are having the thermal conductivity in the ratio of 1:2:4. So the temperature drop in the ratio of, obviously, let us say obviously in inversely proportional, that is 4:2:1. So here the correct answer is C. A closure system undergoes a process 1 to 2 for which heat and work transfers are 110 kilojoules and 60 kilojoules respectively. If the system is returned to state 1 and heat transfer in the process 2 to 1 is minus 30 kilojoule, what is the work done during the process 2 to 1? So it is a closure cycle, because here the first process goes from state 1 to state 2 and then it is returned to state 2 to state 1. That means it is a closed cycle. For a given thermodynamic cycle, cyclic integral of heat transfer is equal to cyclic integral of work done. That is, the heat transfer in the process 1 to 2 plus heat transfer in the process 2 to 1 is equal to work transfer in the process 1 to 2 plus work transfer in the process 2 to 1. Here the heat transfer in the process 1 to 2 is given by 110 and heat transfer in the process 2 to 1 is given by minus 30, and here work done in process 1 to 2 is 60 kilojoule, and we'll have to find out the work done in the process 2 to 1. So just simplify this equation so that we can get here it is 80 minus 16, which is equal to 20 kilojoule. So it is a positive value, that means work done by the system. So the correct answer is A. A is the right answer. In a reaction turbine, the heat drop in fixed blades is 10 kJ per kg and the total heat drop per kg per stage is 25 kJ per kg. The degree of reaction for the turbine is, and the options are 40%, 60%, 66.67% and 80%. So here we have to find out the degree of reaction for the turbine. Degree of reaction for a turbine is given by the ratio, that is the difference between the heat drop, the total heat drop per stage and heat drop in fixed blades by heat drop in the total heat drop per stage. That means here let us say the total heat drop per stage minus heat drop in fixed blades. And total heat drop in heat drop per stage. So which is equal to 25 minus 10 by 25 into 100, let us say, which is equal to 40%, and the right option is A. A is the right answer. During sensible heating of air,